All right, guys, in this video, we're going to continue on with the spreadsheet analysis that this lab requires. I know it's not pretty and it's not fun, and we've not done this. This is the most work we've ever did for any lab. At least that's what it sounds like and feels like and smells like and looks like. So here in part C of the analysis of the samples, again, this could change. It looks like in this particular year, we had 4 blood samples that we analyzed, and there is a chance that you will not have 4. There's a chance that you'll have more, or you could have less. And then it also looks like they ran this one in triplicate, and that one in triplicate, and this one in double, and that one in duplicate or duplicate. And we did not. Some of them, we maybe ran all of them in duplicates. We maybe ran all in triplicates. We maybe just ran them one time. Again, your video is going to tell you what we did. So based on 2024 data, I'm only going to focus on maybe the first 2 samples just to kind of repeat the process over and over. And then that way you can see how we handle the data from the sample reports. All right, so let's talk about the sample reports for a moment. As far as the sample reports go, I want you to kind of keep in mind, make sure that you look at the top of your chart and make sure that you know what is what as far as a name goes, right? That's the thing. So here is S1B, and that looks like it could be sample 1, and this was the second round, so the second run. So we probably labeled them as S1A, S1B, and S1C for this batch. But this just gives you one example, and that's it. And then on the report, you're seeing that here's 5825, and we already identified that that was going to be ethanol for us. And then 7.907, this was going to be our internal standard. So those numbers could change and slightly move around a little bit, but they shouldn't do too much of wiggle at all. So I know that the retention time for ethanol and the others were 5.6. This is a little slightly off. It's not bad, but it's slightly off. But we'll go with 5.8. There, something could have happened with the flow for this run, but I think it's good. All right, so just as before with our samples, we're going to come down here to the report, and we're going to see 5.825. There it is, and it says the area is 1922. And then 7.907, there's the internal standard, and there's my area, 51221. So these are the areas, just like my standards, that I need to input into the Excel spreadsheet. So here in part C, that is what I've done. Now, I did them for multiple samples. You already know how this works. So here's sample 1A and sample 1B and sample 1C, and then 2A, 2B, and 2C. And I didn't even bother to put sample 3 and 4 in there. They ran them. They have data. I don't want to use this as an example. I don't want to create another 15 videos, but we'll just keep it with the top 6 for now. All right. So just like before, with the idea of internal standards, we are going to hit equal, and we need to calculate a ratio. So it is the ethanol area divided by the propanol area, and then I'm going to hit enter. So this will create a ratio for me, and that ratio is basically what we did up above when we made some standards. When I click this cell box, I'm going to click that number again. In the bottom right-hand corner, there's a small square. It's a little box. I'm going to click it, and I'm going to drag it down. Notice it highlighted that area, and then I release on the mouse. So it's going to apply that calculation all the way down. I don't have to keep entering them in. That's great news about it. So I'm going to click that box, and I'm going to delete that number and delete that number. That is an error code, which means there was nothing there, so it didn't know what to divide by. So there's our ratio that's now been calculated. All right, so now using that ratio, I need to calculate the percent based on the internal standard curve. All right, well, what does that mean? Okay, so here's the deal. Here's our internal standard curve. Y equals 0.496x plus negative 0.0006. All right, well, ratio was plugged in for the y-axis, right? So that means the ratio needs to go in for the y variable. So I'm going to use a little bit of algebra now. 0.0375 is the ratio from that sample, equals 0.496x, and then it is a basically minus 0.0006. All right. So in order to calculate the percentage based on this setup, I need to input some numbers. And I need to be careful with how I input them here. All right. If it makes you feel a little bit better, we can keep the plus and we can put a negative here. That works. I mean, that's how it is in Excel spreadsheet, so why not? So I need to solve for x, and I'm going to get Excel to do the calculation again for me. I don't want to do this by hand. I want Excel to do it. So I'm going to click that button or that cell. And I'm going to hit equal. So that way it knows to do a calculation. I'm going to open the parentheses up because we need to do this in 2 steps at least. And it looks like I'm going to take 0.0375. So I click on that number. And we need to get x by itself. So I need to get rid of this negative 0.0006. The way that this is written, it's plus this negative number. So I probably need to do the opposite of add, which is subtract. And I need to subtract that negative number instead. Well, when you subtract 2 negatives, 2 wrongs make a right, and that turns to a positive. Okay, well, anyway, Excel knows what to do. So then I'll close that parentheses back up. All right, so there's our first step. That gets rid of this number that's surrounding the x, and now I need to go in and I need to get rid of this 0.496. That's 0.496 times x. I need x alone. So the opposite of multiplication is division. So I'm going to divide by 0.496. And I can click that box. It's already in there. I can get Excel to do that for me, and I hit enter. So this is the percentage that's based on the internal standard curve. This person has a 0.077%. 0.08 is legal limit. Woo, dog. This person knew when to stop. This person knew when to drink that last glass of water before they left the bar that night, before they got behind the wheel. But by definition, this is not greater than 0.08. So the blood alcohol test would say this person's under the legal limit. It's not 0.08 or greater. This is 0.077. All right, so I'm just going to continue to do that all the way down. But, if I decide to copy and drag, that's great. But it's also going to copy and drag this area as well. And I don't want it to do that. I want 0.496 to stay 0.496. I want 0.0006 to stay that value. So the way that we do that, I'll click on that box, that number again. Up here in the top where it says f of x equals blah, 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 blah. I'm going to click in that function, that cell where I inputted it in. And look, this is a purple box, 0.496. So here's the purple, that's B35. So I'm going to put a dollar bill in front of D, or B, and I'm going to put a dollar bill in front of 35. That locks that cell into place so it does not change when I begin to copy. Here's the red cell. It's 0.0006. That looks like it's in column D, number 35. So here's the red number. So I'm going to click in there. I'm going to dollar bill in front of the D. And I'm going to dollar bill in front of the 35. Again, that way when I click and drag down, that number is locked and it will not change. So I hit enter. All right, so my number didn't change. It wasn't supposed to. The only thing I did was lock cells. I didn't do anything to a calculation. So now when I click that number in the bottom right-hand corner, there's a box. I'm going to click it, and I'm going to drag down. And that applies that calculation to everything. Nothing really here. I'm going to delete that value. So it looks like these are the values really close together for sample number 1. Sample number 2 was definitely not drunk, 0.02. Maybe had some drinks, but not enough to get drunk, but had some alcohol in their system. So that for sure definitely is going to be legal as well. We're looking for 0.08 or greater. There's a column here that says actual. We're not going to do anything with the actual column for our samples. They're samples. We don't know what the actual values are. These are blood samples that have been submitted by strangers. They have pulled them. We're just here to analyze them. I cannot tell you what those real values are. That's why we're running the equipment, and that's why we're reporting the numbers and doing the calculations. We're trying to tell you what the numbers are. But I do not have a guide to go by for actual numbers here. Here's another column. I'm probably going to delete this. This is a percentage based without the internal standard. So they want you to do the calculation again, but this time using the equation that came from the regular calibration curve. What you're going to see is that these values are close, but they are different. And by definition, if we're using auto-injectors, we should be using internal standards every time to report data. That's always the best practice. So in your version of the spreadsheet, I'm probably going to delete that because it doesn't really quite make sense. I just wanted you to compare them for this particular year. And by the time that you get this, I might decide to do away with it, and I probably will. We're only going to base it on the internal standard curve because that's prim and proper. Again, based on the internal standard curve percent errors here, this does not make any sense. So that's why these are grayed out. We are not calculating errors because we don't know the actual values. And then based on the original curve, you're probably going to see that entire 2 columns get deleted because, again, those are going to be close. They're going to be really on top of each other. But it's always best practice to do internal standards because we are using auto injectors in order to calculate these numbers and report the data. Again, good lab practice is what that is. All right, so as far as samples go, I would continue to do that with number 3 and number 4. And then I would still calculate the ratios all the way down. Plug those ratios in for the Y variable, solve for X, and you will get a percentage based on that value, and you're looking for something that is greater than 0.08. All right, so with that said, we're going to stop the video here. In the last video, we're going to focus on the quality control samples. So these quality control samples are something that we have made. The lab has given them to you. You're running them along with your samples, and we want to know, does that data make sense? Is it really close to what we prepped? Yes or no? So in the next video, we'll talk about that one, and that will probably finish this lab experiment up.